All right, welcome back, everybody. This is the end of Unit 1. So this is the Unit 1 review. So this is, again, this whole chapter has been things that you should probably already know from previous classes, like graphing lines, identifying functions and taking inverses and things like that. So it shouldn't be anything really crazy new. But it's really important to really be familiar with these things so we can use it throughout the year. So this is a quick review of things that we should know. All right, so the first thing is write an equation of a line. So we are looking for y equals mx plus b. So again, y minus y1 is equal to mx minus x1. This is really kind of the formula that you really should probably be getting familiar with as far as lines are concerned. Plugging and chugging in this one, we have y minus y1 is equal to m x minus x1, multiply in this case subtract 6, so that says y is equal to 3x minus 9. Okay, vertical line, this one's easy. That implies x is equal to. This is a vertical line, so x is obviously equal to 0 according to the point. Horizontal line, that's easy. That's a y is equal to. Y is equal to 2 according to the point. All right, here, yes, I know that I usually do y minus y1 is equal to mx minus x1, but that really doesn't make any sense in this case unless you really want to think of this as being the point 0, 3. But in this situation, because they spoon feed us this information, I'm going to write this with y equals mx plus b. Again, the b is the y-intercept. So this is y is equal to negative 3x plus 3. Okay, determine whether the graph is symmetric about the y-axis, origin, or neither. This is an x to the 1/5. I believe this would be an origin. I believe this would be something like that. I'm just going to quadruple check with my calculator here. X to the 1/5. This is the same thing as saying the 5th root of x. Yeah, so the upper right is the same thing as the lower left. This is an origin kind of symmetry. Even, odd, or neither. I see that this has an exponent of 2 and this has an exponent of 0. This is even. Again, you're looking at just the exponents of the x's. So even if this number had an exponent on it, I'm not really concerned about it because this has an x to the 0 attached to it. All right, so here I have a 5, 3, 1. These are all odd numbers. This is odd. 1 minus cosine. Okay, now you're kind of getting out of my element as far as knowing if it's even or odd. So here is one that I'm going to pretty much be graphing. So 1 minus cosine no, no, that's fine. That's fine. I'm sorry. Because thinking of graphing, usually things go from -1 to 1. However, this is kind of like saying this. And so this is moved up 1. Okay, so usually it starts at 1. This is going to start at 2 and go down to 0. And it's usually goes top to bottom. Now it's going to go bottom to top. So it does this. But what I notice is it's symmetrical still. It didn't get moved side to side. So it's symmetrical still on that y-axis. So it holds that y-axis symmetry. So this would be even. Secant tangent. Secant tangent. The secant is a 1 over cosine. Tangent being a tangent. Okay, so this is a secant tangent. And so notice what this is looking like as far as the origin is concerned. Just gonna want to make sure that I'm not saying something bad. Yeah, so it looks something like that. So the upper right is the same thing as the lower left. This is an origin. This is an odd function. Okay. Next one. We have x to the 4th plus 1 divided by x to the 3rd minus 2x. That's an odd. Okay, so again, notice how the upper right is the same thing as the lower left. That's an odd function right there. And 1 minus sine. So again, I'm kind of thinking of it like this. So this will be up 1, so it's going to start in the middle, ends in the middle, middle is the middle, and then it usually goes up, down. This is going to go down, up. Okay, but notice how this right-hand side is not the same as this left-hand side. It's not the same. And there's nothing down here at all. So notice that the upper right is not the same thing as the lower left kind of concept. So this is needed. All right. Domain range of the graphs. Graphic. All right. So 16 minus x squared. I'm just going to use my calculator to kind of help me out here. These are kind of goofy equations. So 16 minus x squared. Let's try that again. Square root of 16 minus x squared. Half circle. Oh, duh, this is a half circle, positive half circle. So a circle, x squared plus y squared is equal to r squared. This is an equation of a circle. So notice that if I were to make this radius 4, this number technically would be 16. Now, what does that look like when you manipulate this equation just a little bit? Well, this is 16 minus x squared, and then a square root. Now, technically, that would get a plus minus. When you put in a square root, you put in a plus minus. And so this is still an equation of a circle. So the positive portion would get the upper part of the circle. The negative would we get the lower half of the circle, making a complete circle with a radius 4. However, they don't give us this plus minus in this equation, they just give us the plus. So that is just very specifically the upper portion of the circle. I should have been able to recognize that, but whatever. All right, so this is an upper part of the circle, radius 4. So 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 4, and darken those so people can see them. Upper part of the circle. So 2e to the negative x minus 3. Okay, and e to the x just generally looks like this with an intercept of 1. That's what an e looks like. So a negative x, we'll put it downhill. 2 will make it steeper, so it'll be a steeper version of that. And then the minus 3 would move this down 3. So down to negative 2. So my hypothesis is it'll look, that was supposed to go through the negative 2. So my hypothesis, we'll see if we're correct here, is it'll go through negative 2 and it'll have an asymptote down at this negative 3, and it's going to be pretty steep. Something like that. Let's just take a look. So 2e to the negative x minus 3. I'm going to make my windows a bit smaller. Oh shoot, it went to negative 1. Why did it go to negative 1? I'm just thinking here. Give me a moment to think. I just, why did it go through negative 1? I guess I technically know. If I put in a 0 for x, e to the 0 is 1. 2 times 1 is 1. 2 minus 3 is negative 1. Okay. Okay, my bad. Not a big deal. So negative 1 still has that asymptote at negative 3, something like that, and it goes down like, ooh, I totally skipped over part of the question. I'm sorry. Domain. Domain in this upper one, negative 4 to 4. Notice how they actually do hit those 4s. The range, the low is 0, the high is 4. 13, the domain is negative infinity to infinity, never stops. Range, the lowest it goes is negative 3. Notice how it never actually gets to negative 3. It will never ever actually get to negative 3. It's an asymptote. And then the upper bound is there isn't one. Oh, this next one. Oh, I was noticing that this one was coming. I'm going to kind of change up my graph a little bit, give me something a little bit easier to graph on. All this is just a huge problem of manipulations, just knowing what things do and stuff. All right, so here's what a sine graph looks like. A sine starts in the middle. It goes typically from negative pi to positive pi with an amplitude of 1, and it goes up and it goes down. Okay, so this is your typical sine graph, with this being pi, this being negative pi, and then obviously pi over 2s and things like that. Okay, let's start manipulating this thing. Let's take care of all the movements and things like that. So what I see is that will move that down 1. All right, so that will move the whole picture down 1. Try that one time. It moves the whole picture down 1, down, down, down. There you go. That moves it down 1. And this moves it left pi. So again, here's your pi, left pi. It will move everything left pi. And so I'll just kind of help myself out again and do something like that. All right, so there is our picture with those movements. Outside 2 is the amplitude. So instead of going to a max of 1 and a min of -1, those are multiplied by 2. So it goes up 2, so up 2 and down 2. Okay, up 2 and down 2. The middle stay the same. So it gets taller. And the most difficult one to kind of address is this 3. Typically, this affects the period. The period is 2 pi. And so whatever is multiplying that inside x is a division. So this period is now 2 pi divided by 3. So if this is the period right here, which is still negative pi to pi, what I'm going to do is, notice how this has a distance of 2 pi over, excuse me, as you were. This has a period of 2 pi. What I'm just going to do is just turn those into thirds. So now this has a period of 2 pi over 3. So this kind of purple picture, I'll just manipulate my graph here. Instead of saying that, I'll say that. Okay, so I'll make one kind of clean picture with all these manipulations on it. Start big, and then I'll shrink it down. Okay, so all I'm doing is just kind of stealing my answer here. Okay, so as you were. So this was moved down. It has an amplitude of 2, so it goes up 2 and down 2. So these are our tops and bottoms of the picture right here. The center is still in the center because it was moved to pi, but it just looks like it's upside down. Oops. That's up 2 for my dot. So this is kind of the center line right there. This is the new center line. So this is the center, and I'll take it out to here, and 1, 2, 3, 4 out to there, and then it goes up over here. So it'll be up in the middle, down in the middle. Right there, that's my picture, with this being pi over 3, negative pi over 3. Not that it really makes any difference because this technically goes on and on and on and on forever. All right, so anyways, that is our picture right there. That's my picture. You can do whatever you want. A lot of manipulations in that one. All right, let's answer the questions that are being asked. What is the domain? Well, it goes on forever in both directions, left and right. The range, the lowest it goes is what, -3, and the highest it goes is +1. We could chop. There it is. All right. Here's a piecewise function. Not a big deal. And so piecewise function, I'm going to go with this, the bottom one, the square root of x. The square root of x goes from 0 to 4, and so that would be open dot 1, 3, 5. But notice how it'll stop at 4. You don't technically go on, but because of the rule that we're only starting at 0 and going to 4, so it's that. Because this doesn't have the or equal to on the 0, that's why this gets an open dot and this gets a closed dot. So it does something like that. -4 to 0, I believe it'll be the same thing, just going in the upper opposite direction. So example, if I plug in -4 as my x, what I'm going to get out is a +2. Okay, what I'm going to get out is a +2 from that upper formula. So -4, +2 kind of concept. -1, +1 kind of concept, and then 0, that darkens in that center dot. So that's our picture. Domain, -4 to 4. Range, lowest is 0, highest is 2. Okay, write a piecewise function. What they mean is they want you to write something like number 15. All right, so the equations of these lines, okay, this first line right there, that's y is equal to -1x plus 1. So it has a y-intercept of 1 and a slope of -1. Okay, don't worry about the starts and stops and things like that, but that's the equation of that line. So this is y is equal to, let's see if I can do this a little bit more clean, y is equal to -x plus 1. Okay. This one would have an intercept of 2. That could go on. It's a perfect 45. So that means this equation is y is equal to -x plus 2. Has the same slope and everything, and that is that equation of that second piece. All right, now let's put all the other stuff to it. All the other stuff. So I'm using number 15 kind of as my example. So y is equal to. All right, so the first equation, the blue equation, is -1x plus 1. Now, where does that occur? Okay, so you notice that it concretely starts at 1, but it doesn't actually get, it concretely starts at 0, but doesn't actually get to the value that it would be at 1. So it does go from 0 concretely, thus the or equal to, but it doesn't actually go to the 1. It doesn't represent 1, so it doesn't get the or equal to. So again, that would go from a closed dot to an open dot as far as the inequalities are concerned. Okay, notice that this second line, the red line, goes from a close from 1 to 2. So the red equation goes from 1 to 2. It does represent the 1 and it does represent the 2, thus the or equal to. And so there is your piecewise function. Okay, write the equation. So slope y2 minus y1 over x2 minus x1. I'm going to use the point slope method in this. So y minus, I'll just write it out just again in case you have forgotten. This is what I'm running off of. And so it doesn't matter which point you use. I'll just use 4 or 3, just, I don't know, because I want to. And so here we go. So y minus y1 is equal to m x minus x1 as such. Okay, and so multiply in, add the 3. So when I add, this 3 over here, okay, so I'm going to be adding 3. So what that means is I need to have a denominator of 3 so I can match up the fraction. So this would be 9/3. So that's me adding 3. So y is equal to negative 1/3 x plus 13/3. Okay. Here, the slope. The slope is y2 minus y1 over x2 minus x1. 5/3. I'm going to use this point. So y minus y1 is equal to m x minus x1 plus 0. Okay, find the inverse. Okay, so g of x is the inverse. So g of x. So right now, f of x is equal to 2 minus 3x. Okay, so that means y is equal to 2 minus 3x. Okay, so that's the current equation. So the inverse is x is equal to 2 minus 3y. Solving this, I subtract 2, divide by negative 3. Over here, so that would be x minus 2 divided by negative 3. Kind of cleaning this up just a little bit. This would be equal to y is equal to, you can write this in a bunch of different ways. So what I'm going to do is go 2 minus x over 3 to look like that. It could look like negative 1/3 x plus 2/3. It could look like that. So any version. Just for simplicity's sake, what I'm scared of is people will get this right answer, and then upon their cleanup process, they'll make it wrong. That's what I'm really kind of concerned about. So I would just get your answer and stop. As soon as you know that you have an answer, stop. Okay. Okay, we went over this in I believe the last lesson, showing that if I embed the inverse into the other, you should have they both should be equal to x. So here we go. The f of x is 2 minus 3x, where I have the inverse as being x minus 2 divided by negative 3. And I'm going to show that that should be equal to x. So what I see is I have this negative 3 multiplying in, so that it will cancel out. So this is a 2 plus Okay, so it doesn't become a multiplication, so there's that. And then x minus 2 remains, and I see plus 2 minus 2, x is equal to x. Right, the second part is g, which I have as x minus 2 divided by negative 3. And the f is inside the g, and again, that is 2 minus 3x. I'm going to show that this is indeed equal to x. Dealing with purely the numerator, I see that positive cancels negative 2, so this is negative 3x over negative 3. X is equal to x. All right, let me jot down this. So f of x is equal to 2 minus 3x. And I have g of x as being, I'll just use my line method. So graphing them, so I have the top one, the y-intercept is 2, slope of negative 3 over 1. So 2 with negative 3 over 1. Other one, I have a y-intercept of 2/3 and a slope of negative 1 over 3. So negative 1 over 3, negative 1 over 3, negative 1 over 3, negative 1 over 3, 3. So that, and you can pretty much see that it's looking the way that it should. So again, things that are approximately equidistant from the top side to the bottom side. So for instance, this dot is 1, 2, 3 from the line, and 1, 2, 3 from the line is pretty much there. Oh, that's it? Man, easy peasy lemon squeezy. Okay, so that is the review. Be prepared for a practice test, and I'll try to keep you posted as much as I can on what the test is going to look like. How can you actually prepare for the test the best you can? Again, make sure you're paying attention to the classwork that will, and what we go over in class. I'll try to give you, to the best of my knowledge, what the test is going to look like, and I'll try to hint you in on how we're going to be taking the test and all that sort of stuff. But again, if you have any questions about this review, please bring it up. I'd be happy to help you out. Have a good day.